So we're going to be talking about basic transformation today of a function, and this is a pretty important basic to know as we transform different function. And we're going to be starting with this basic equation, a times parenthesis f bx plus c, and then plus d at the end. And then we're going to be talking about all the different parts here. So if absolute value of a is greater than 1, it will stretch. And then if absolute value of a is less than 1, it will compress. And if the a value is less than 0, it will be flipping over the x-axis. So it will be like a reflection of the x-axis. And then moving on to the b in the equation up top. So b will be stretching along the x-axis. So if absolute value of b is greater than 1, it will stretch. And if the absolute value of b is less than 1, it will compress. Is what you thought. But it actually is different from the previous one and has a different pattern. I almost gotcha. And it actually, if the absolute value of b is greater than 1, it actually compress. And if the absolute value of b is less than 1, it will be stretching. So be careful to remember the difference between the a and b, because they will be doing different things. And if b is less than 0, it will be flipping over the y-axis now. So it will be reflecting over the y-axis. The last two we'll be going over will be the addition of c and addition of d. These are pretty simple. So c will be displacing along the x-axis by minus c. So say if we have plus 5, it will be going to the left 5 units. And then if we add d, it will be displacing over the y-axis by d. So if we have plus 5 at the end, it will be displacing up 5 units. So we're doing a few practice problems to become more familiar with these. So we see x squared plus 2x plus 6, and we notice that it's not in the format that we saw. So we have to find a way to make it into the format that we saw. So you see we are making the x squared plus 2x plus 1, and then add a 5 at the end so that we can make that into x plus 1 squared. So now it looks like the format that we had in the previous paper, where we see 1 will be the displacement over the x-axis, and the plus 5 will be the displacement along the y-axis. So you see the resulting graph will be just a shift up version of the parent function x squared. So if you're able to just do that, it's not that much of a problem. Okay, so we'll be going over the second example problem, which is written incorrectly on the paper. It should be negative parenthesis 5x plus 2, the whole thing squared, not the negative inside. And the parent function you see on there is negative x cubed actually, so it is easier for us to transform. And so we don't have to think about the negative that's in our problem, so we just have to do the 5 and the 2. So starting off with just 2, we know that that is just the shifting of the graph to the left by 2, because that was the thing that we saw from the previous page. And the factor of b, which will be the compression horizontally by a factor of 1/5, because it's 5. So it'll be a factor of 1 over whatever the number is. So in this case, it'll be 1 over 5. So if you do that, the graph will look something like this. So it's not that hard if you take it step by step, and it's always good to start with a parent function, like x cubed, or negative x cubed in this case. So if you take those into account, you should be fine with transformation.